Welcome to Lesson 69 of Course 2. In this lesson, we're going to talk about proper forms of scientific notation. We're going to combine powers of 10 to write numbers in scientific notation. This is probably in the top 3 for the toughest concepts for students to understand. So please take your time as you go through this lesson. Don't skip anything. Don't move ahead. Take down notes and make sure you understand it before moving on. There isn't any new vocabulary, so let's just get started here. So when we write a number in scientific notation, we usually put the decimal point just to the right of the first digit that's non-zero. So if you've got this 4,600 times 10 to the 5th, normally we would take and we'd put the decimal right after the 4, and then we'd come over 1, 2, 3, 1, 2, 3, right? And we'd write 10 to the 4.6 times 10 to the 3. We've already got the 10 to the 5. So what this really equals is 4.6 times 10 to the 8th, because we already had 5 and then we added the 3. So that part's really pretty easy. But just understand that because we've already had to move over 3 spots, we've got to get those 3, account for those 3 additional powers of 10. And then we know that when we multiply exponents, we add them. So that 10 to the 3rd times 10 to the 5th becomes 10 to the 8th. So let's take a look at this. I'm going to do this first one for you, and I'm going to give you a little different idea of the way that I do it, and you can decide if you like that or not. So first thing I want you to think of is like money and how you normally have a decimal point for values. And when you go to the left, when you move to the left, your money goes up. So if you've got, say you've got 10 cents, and all of a sudden I put a 1 here, now you got $1.10. That's more money. So that is a positive thing. And if you end up going this direction, then that's a negative thing. So think of anything to the left of the decimal. If you take the decimal and you move it to the left, that things are getting bigger. If you move the decimal to the right, things are getting smaller. See if you, I know that's kind of backwards, but hopefully it'll make some sense. Okay. And I'll show you both ways of doing it on this particular example. So 2.5 really, 25 really, when you write it, when you put it here and you move 1 to the right, that's going to be 2.5 times 10 to the 1. And then when we add times that by 10 to the negative 5, we know we're going to get 2.5 times 10 to the negative 4. That's one way of doing it. The other way of doing it is that if you will just find where the decimal is currently at. Now we know the decimal is right here because that 25, the decimal would come after the 25. Right? The decimal would be right here. So if we move it 1 to the left, that means it's a positive 1. So positive 1 and a minus 5 equals negative 4. Okay, that's another way of looking at it. The reason I say it is because here it gets a little bit different. All right, so now here, if we move it 1 to the right, that's a negative, right? That's getting smaller. So we're going to say that's going to put it at 2.5. When we move it 1 to the right, it becomes 2.5 times 10 to the negative 1. And then we do that times 10 to the negative, or 10 to the 4. We end up with 2.5 times 10 to the 3, because 4 minus 1 is 3. All right, that's one way, and that's the only way when you're doing it when you already have a decimal that's present. Okay, so let's do another one. This one here doesn't have the decimal, so I know that the decimal would normally be right there at the on the other side of the 2, because that number's 24. If I move it 1 to the left, that gives me 2.4, but because I moved it to the left, that's a positive. So times 10 to the 1 times 10 to the negative 7 gives us 2.4 times 10. And what's negative 7 plus 1? Negative 6 times 10 to the negative 6. All right? Starting to make a little more sense? I hope so. This one here, we have the decimal point. The only reason I teach you the way I've taught you is because sometimes they don't have the decimal, and those are the ones that get confusing. When we have a decimal and move one to the right, that makes it 7.5 times 10 to the negative 1, because we went to the right, times 10 to the negative 8. We get 7.5 times 10 to the negative 9, because we know that we add those exponents together and they equal negative 9. Okay? I'm going to back up, and I want to do them again because I think it's important that you have the practice. All right, so let's take a look at this. See if you can do this. See if you can remember the right way of doing it. Pause the video and do it. I've got 25. I know my decimal's right here. If I move it to the left, that's 10 to the positive 1. Because when we're going left, we're positive. We're going right, we're negative. So if we go left, we've got 2.5 times 10 to the 1 times 10 to the negative 5. We add those two together. We end up with 2.5 times 10 to the negative 4. Okay, let's do another one. All right, so how would you do this? What would you do? How would you solve this? What's the answer? Well, we'll move that over 1, so that's a negative 1. So that's going to be 2.5 times 10 to the negative 1 times 10 to the 4th power. Add those exponents together, you get 3. So you get 2.5 times 10 to the 3rd power. Okay, enough of that. Let's move ahead here to let me just give you one. Okay, I'm going to use this here slide here to write one for you, and I want you to see if you can do it, please. All right, so let's say that it's 0.075 times 10 to the negative 8. How would this change? How would this change our answer? Well, if our decimal's here and we got to get to scientific notation, how many times are we going to have to move this to the right? We got to get to the right-hand side of the first number that has no trailing zero. So we got to go 1, 2, right? So now we got 7.5 times 10 to the negative what? 2, because we came over 2 times 10 to the negative 8. So this becomes 7.5 times 10 to the negative 10 when it's 0.075 instead of just 0.75. Hopefully that makes a little more sense. Practice these, please understand this. I know it's hard, but you'll get it. Just remember, if you go to the left, make it a negative 10. If you go to the right, make it a positive 10. But don't confuse that. The problem I have is that if you've already got the decimal point, people tend to get confused, or they want to confuse it when they're just doing, say, 7,500, and they say turn this into scientific notation. Then you're going to go 1, 2, 3, and you're going to go 7.5 times 10 to the 3, which is the correct answer, where I've just told you that it would be negative 3. It's only negative 3 when you're taking something that's already in a form of scientific notation and expanding it and adding more to it. So you got to keep those two completely distinct and separate from each other and not confuse them. I don't want you to be confused. If that's confusing, sit down with me and we'll do it another way that makes more sense to you. All right, here's your problems. 4A and B are scientific notations and scientific notations. For them, I want you to just write your answer. When you submit it, put like 3.5 times 10 to the 6th power, because I know you can't put hypertext in. So go ahead and solve these. Do them tonight. We'll practice this a lot tomorrow in class so that you are able to do it correctly. And thank you for watching the video, and we'll see you tomorrow.